video, we are going to solve a question on transformation from the EGCSE 2025 mock examination paper 4, and this is question number 9. It says use the grid to draw triangle T with vertices 1, 1, 2, 2, and the 3, 3. So these are the vertices. Now for simplicity, I'm not going to plot this thing on this grid, but rather I'm going to plot it on GeoGebra. Let's go to GeoGebra. Now on GeoGebra, we are just going to draw the triangle with vertices 1, 1, 2, 2, and 3, 1. Just like that, we have a triangle. Maybe let's just leave the labeling. Now we have our triangle T. Next question. The next question requires us to transform T with the translation vector -6, -5. So let's go and transform that triangle with the given vector. Back to GeoGebra. Maybe I should zoom this thing out. It's -6, -5. Now let's check. For the first point, but on GeoGebra you can just translate directly. Let's translate this. With the vector -6, -5. And that's your image down. That's the vector there. Maybe so that's the image. Back to the question. You are required to enlarge with a scale factor 3 around the point 0, 0. So we can do it just directly on GeoGebra. Let's go to GeoGebra to enlarge. We are enlarging at the center 0, 0, scale factor 3. Let's enlarge. There is a button for dilate. Then select the object and then click the center. It's 0, 0, scale factor it's 3. There you go. But then how do you find the enlargement manually? Let me take you through the process of finding before that, the scale factor is 3. And then the scale factor 3. Let me go and write. The scale factor is 3. And then multiply each of the coordinates by 3. So the first coordinate was 1, 1. So the answer is going to be 3, 3. What does this mean? So now go to the center of enlargement and try to locate the vector 3, 3. We were told that the center of enlargement is 0, 0. So let's try to find it. If the center of enlargement is 0, 0, then from 0, 0, we will need to go 3 units to the right, and then that's 1, 2, 3, and then 3 units up, that's 1, 2, 3, and we get the first coordinate. Similarly, for the second coordinate, 2, 2, just multiply it by 3, you are going to get 6, 6. Then go to the center and try to locate that 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, then 6, and that's the result. For the last one, it was 3, 1 multiplied by 3. It's going to give you 9, 3. Always start from the enlargement center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. 1, 2, 3, and that's the resulting image. Next question. Rotate. For rotation, you are always going to use your tracing paper through 0, 0, 180 degrees from R to form triangle R. Let's go and draw triangle R. This is triangle Q. Then we need to rotate this around 0, 0 by 180 degrees. So to rotate that, just select rotate around 0, 0, 180 degrees. And there is your resulting image. And then now we need to reflect T along. We need to reflect T, that's number D, reflect T in the line X equals to -2. Name your image X. S rather. Let's go to reflect T along the line X equals to -2. So first of all, I'm going to draw the line X equals to -2. And then reflect. So whenever you are reflecting, you are going to count from point A to the line of reflection, or rather the mirror line. Let's count 1, 2, 3. That's 3 units. Then from this one to the other side, it must also be 3. So 1, 2, 3, which means it's going to be there. Now let's use the automatic reflector. Here, reflect this along that line, and there is your image there. And then you are just to call this one S. Seems like we are done. Now describe fully the transformation that maps P to T. P to T. Let's go to GeoGebra and check P. Talking about these two green triangles. What's their relationship? So we are saying their size has not changed, neither
flipping or resizing it. How to identify a translation. 1. Same size and shape. The figure remains congruent to the original. 2. Same orientation. The figure does not turn or flip. 3. Every point moves the same distance in the same direction. All points shift equally. 4. Vector notation. A translation can be described using a vector, e.g. begin matrix x, y, entrix, meaning the figure moves x units horizontally and y units vertically.
Has their orientation change, so it must be translation. What's the translation vector? It's going to be, let's count from C to C. That's 1, 2, 3, 4, 5, 6 units to the right, and 1, 2, 3, 4, 5 units up. So it's translation. It's translation by vector. Let's write this as a vector, not as a coordinate. Positive 6, that's 6 to the right, 5 up is positive 5, but right is it as a vector. Next question. State the matrix for the rotation in C. Matrix for the rotation in C. Rotation 180 from, so we are relating T to R. So what do we do when you want to find the matrices for rotation? It's this one. From identity matrix. What's the identity matrix? It's 1, 0, then 0. And that's the identity matrix. So what happens? The first column is 1, 0. Treat that as a coordinate. So after rotation through 180 degrees, where does that coordinate go to? 1, 0. After rotation through 180 degrees, 1, 0. Here is the point we are talking about, 1, 0. So if we rotate that point through 0, 0 by 180 degrees, it goes to -1, -0. So the first column of the matrix is going to be -1, -0. And then the next column, the second column in the identity matrix, has 0, 1. So treat it as this coordinate here. There's this coordinate here. And then rotate that through 180 degrees. About that center, where does it go? It goes to 0, -1. So the first column, it's this one, -1, 0. And then the second column, -1, 0. The first column went to negative 1, 0. So this is negative 1, 0. And then the second column went to 0, negative 1. So this is 0, then negative. So this is the matrix they are looking for. And basically that's how you find it.